So now we're going to create the core for our animation, and as we saw before, the core is just an icosahedron, but moving on the animation, we want this core to open up. So the idea here is to work on a single piece of the core and then replicate it to create the whole icosahedron. And as you can see, the core has some geometry carved in. The quickest way to do something like this would be with some Boolean operation, but we want to create this texture inside Substance. That means we need some good UV and some good topology, so the Boolean is not the perfect way to do it. We are going to use some other techniques. So back in Houdini, go inside the core start geo, where we started to create the animation for the core. We are going to also do the modeling part here. So we are going to create a circle and a transform node. Highlight the transform node and let's zoom in. We want the circle to be 3 division, we want to be an open arc, and we want to rotate it minus 30 degrees in the z-axis. So we'll have something like this. This is basically the outline of a single piece. So now if we duplicate the shape and merge it together, we're going to use a skin node after it. And let's quickly see the merge so we can transform down this other shape and increase the subdivision, something like 24. Now the skin node, as you can see, even if the two circles has different amount of division, they are multiple one of each other. So the skin node is actually capable of creating some good topology, and I can go from a triangle shape to a circle one, like I have here, and create some carving effect without destroying my topology. So let's create all the topology we need for the outer face. For the outer circle, I already know that my size is going to be 0.6. Now let's put the display flag on the merge and let's create the other geometry we need. The second circle, we want it to be 3 division. And let's say we want a size of 0.5. Then we want to copy it again, and for the third one let's put 0.45, so we'll have another little division here. Copy it again a fourth time, let's plug it, and this time we want this to be the circle section, so let's decrease the size to, let's say, 0.148, and this time we want to increase the division to some very high value, but remember we need to be multiple of 3, so let's put 96 on it. Duplicate it again and let's plug it to the merge. For this other one, let's decrease it even more, maybe from 118, yeah. Duplicate it again. For this one, an even smaller one, let's say 0.028, and another final time just for the center point, so scale it to 0. Now, if we go on the skin node, you will see a bunch of problems. That is because the order of the connection on the merge node, it actually matters. Right now it's all messed up. So to quickly fix it, let's press Y and drag across the connection to delete it. Now we can select all the transform node and plug it together. In this way, the order will be correct and we have our basic topology for the outer face. Now let's just grab a fuse node, because at the center we use the circle scaled on 0, so we have a bunch of overlapping points. After the fuse node, it will be only one point. And let's create a null. We will call it out face and mark it as green. Now we want to start to select the face we want to carve in, and we want to do it in an alternate way. Basically, if we carve in the center, then we want to skip a loop, then carve this one, skip the other one, and carve the last one. And since we used the skin node, we ended up with each loop counting 96 polygon, which is the highest value we set on the circle. Which means we can actually select those polygon we need to carve in with a group by range. So let's take group range and highlight it. In here, let's call the group name carve, and we said we want to select 96 polygon, meaning a full loop, and skip another loop. So 96 by 2, which is 192. And there we have our first curve selected. So now if we take a poly extrude node, we want to extrude the curve group. So select it right here and let's put negative 0.02 for the distance, and we don't want to output the front. So we have our first curve. But as we see from the reference video, we also have some curving occurring across the face. So to create those other curves, before the actual extrusion, let's create a group node and plug the group range into the left input. Now we want to use a line, just a simple line on the y-axis with a polywire to give him some thickness. So we have something like this, but we want to decrease the thickness to something like 0.07 and maybe increase the division to 10. So now if we plug it to the right input of the group, we want to change the type to points, otherwise we can't use this bounding object because it works only on point or vertices. So we have something like this in the selection, and now we can copy and transform this line so it will be something like this. You can put 120 and we want 3 copies. So we have this selection. But now for the extrusion, we want to convert this group to a primitive group because right now it's a point group. So let's take a group promote and we want to call this group as curve2. And let's plug it to the group promote. We want the group name to be curve2. We don't want a new name. And we want to convert it from points to primitive. Now to exclude those inner polygon, we just need to move the origin of the line on the y-axis until we have just this left. Then we plug the group promote to the poly extrude, and on the poly extrude we just want to add the other group to the extrusion. And of course now the line is too long, so we want to decrease the length until it's contained inside the final loop. So something like this. And we have our basic carving effect. Now before we start to add details to the surface, we want to create some basic UV because it will be much easier to deal with without some bevel effect or other details. So let's drop down a UV flatten node. And the way it works, if you activate the tool, it splits your viewport in two. You have the perspective and the UV view here, and you have the tool operation right here. By default, this cut or sew is selected, and in the viewport, if you press Shift and click, you can cut an edge. If you press Ctrl and click, you sew it back together. So we want to cut, so press Shift, and we want to cut all the corner of our outer loop, so here and here. And now we want to also cut the outer corner of these outer pieces. So let's cut this one and the inner one. So we have done, and we want to deselect this enable manual layout. So we will have something like this, and it will be fine for our basic UV. Now we want to apply some bevel, so let's take a group node after the UV flatten. And let's switch the group type to edge, disable the base group. We want to include by edge and enable the minimum and maximum angle, and until we have all the sharp edge in our selection. So this one. Then lay down a poly bevel node and also call this group name to bevel. And we want to bevel this group. Let's set the distance to 0.26. Sorry, 0.026. So we have something like this. And we want more division, let's say 8. So we have some nice smooth effect on this edge. Let's check, and we need to make sure that also those edges are included in the selection, so we need to increase this one. Yes. Alright, now it's correct. Alright, now we want to create the geometry for the side part. So let's lay down another group node. And this time we just want to switch the type to edge and manually select this outer edge. You may already notice that this part is not going to be full procedural, and that's because we don't need it to be. This is the main character of our shot. We already know that we need just this one, and we need it to be just the way we are designing it. So as a general advice, always evaluate what your needs are. The fact that you're working with a procedural software doesn't mean that you need to be procedural in everything you do. Make things procedural takes time, and you don't want to waste, let's say, 2 days on a fully procedural setup for an object that you're not going to need never again. And honestly, if one day I'm going to need this kind of setup, I can always go into this scene and grab whatever I need and start from there. So now let's rename this group to sides, and we want to drop down another polyextrude node. We want to extrude this sides group, and we don't want to use the distance parameter. We want to enable the transform extruded front. Let's set the transform space to global, and we can move it back to the z-axis to -0.4, and we want to scale it down by half, so 0.5. So we created the surface for our side, and let me disable this show UV texture. The problem is right now we have a straight shape. If we look at the final video, we have like a hollow sphere shape inside the core. So let's create a sphere and put the template flag. We want this to be a polygon type with 20 as frequency. Reset the default radius to 1, and let's scale it down and move it on the z-axis. So let's say 0.8. And I want a size of, let's say, 0.58. So now we can use a boolean to cut the side shape. So let's take a boolean node, plug the extrude and the sphere, and we will end up with something like this, but we don't want this inner surface for now. So let's change the set A to surface, and we have our side surface with the curvature. But the problem now is that the boolean left a bunch of points that we have to delete now. And there's actually a very quick way to delete those points. Here I marked with green all the points that I want to keep, and in red the points that are generated by the boolean. Now, if we look on the mesh, the green points are always connected to 3 other points. They have one connection to the other side by this edge, and 2 connections on the same side. On the other end, the red points, they are not connected to the other side, so they are connected to only 2 other 2 points on the mesh. And we can use this information in Vex to tell Houdini to delete all the points that have less than 3 connections. So let's see how to do it within a point wrangle. So let's drop down a point wrangle. Let's plug it after the boolean and call it count. Now, the function we are going to use is this one. It's called neighbor count, and it returns the number of points that are connected to the specified point. And that's exactly what we need. This function will tell us how many points are connected to the current point. It needs to be stored in an int variable. So let's create an integer variable, call it count, and we will use this function neighbor counts. It wants the geometry input, so 0, and the current point number, so at ptnum. So now we can store it inside an attribute. Let's create an integer attribute, call it count, and store the variable inside it. So if you go on the geometry spreadsheet, you can see that the count is counting the connected points. And we don't care about the 5 or 4 one, those are the one on the bevel side. We're just interested in the points that are less than 3, so all these ones that are 2 as count. So now here we can say that if count is less than 3, we will remove that point with the remove point function, and it wants the geometry index, so 0, and the current point number. And just with 3 lines of code, we deleted all the points we wanted to delete. Now we want to create the surface for the back part, so let's take another poly extrude, and we want to manually select this edge loop, so just double click and enter. And like before, activate the transform extruded front and scale it back to 0. Now the problem is, just as before, we want a spherical surface, and this is not correct. So first we want to split the geometry in two, so we can work just on this back part and then later on merge back the side and the front. So to do that, we just need to activate this side group. We will call it back. This will create a group with only the new faces, and now we can use a delete node to split the geometry. So let's take a delete node and just say back here. Delete non-selected, and there we go. Also, we want to increase the poly extrude division. Let's put 20, so we have some nice subdivision to work on. So to properly deform this shape, if we put a template flag on the sphere, we can see that we basically need to deform it along the sphere. So we can use a raise up to project this piece on the sphere itself. But as you may recall from before, the raise up requires normal. So let's drop down a normal node after the sphere. We want to set it to points. And also this one needs to have some good normal, so we can transfer the normal from the sphere. So we plug the delete node on the left and the normal node on the right. Now on the attribute transfer, we can turn off primitive and set normal to the points tab. So if we display the normal, we can see that we have transferred the normal from the sphere, and now we can use a raise up. So plug the resulting attribute transfer on the left and the normals coming from the sphere on the right. So now let's take a null for visualization and disable the normal. You can see that the shape is better than before, but we still need to do some adjustment. So let's take a smooth node. After the ray, we want to smooth this mesh. Let's say 50 as strength. So we fixed also the internal topology and we have a correct shape. Now we just need some normal for visualization, and there we go. Now we want to merge the other parts together, so we can delete those nodes, duplicate the delete one and say selected. So we can now take a merge node and merge these two guys together. We can delete this null as well, and there we go. But now we actually have to split the mesh again, because we have UV on the front part, but we need to create UV as well for the side and the back part. So let me rearrange things a little bit. So we can easily delete the back part because we still have that back group, but we don't have the side group, and we can create it going back to the first poly extrude, the second one where we created the sides. We can enable the side group here as well and call it side. So now by going back here, you can have also the side group deleted as well. So this will be the front part we don't want to touch because we already have UV. And duplicate this delete node and say delete non-selected. So now we can add UV just on this mesh. So now we want to take another UV flatten node and let's enable it. This time, instead of selecting the edge manually, I already know I want to cut all the sharp edge. So we can do it with another group before the UV flatten. We want to set the group to edge. Disable base group include by edge, and let's find the value to take all the edge we want. And the reason those edges in the middle are not considered is because they are not connected, so we don't actually need to cut those edges. But if you want to include, for whatever reason, any unshared edge, you just need to activate this checkbox and you will have all the edges that are not connected to other surface. Now let's call this group seams, and on the UV flatten, let's check the seams group on the flattening constraint. Also disable the manual layout, so we will end up with something like this. Now we can merge those two guys together and we can drop down a fuse to connect back again those edges at the geometry level. Now we want to apply some other beveling to this sharp edge on the sides and on the back part. So let's drop down a bevel node. And we want to set our bevel edge within a group. So let's take another group, set it to edge, and we will call it bevel. This time we will manually select all the edge we want to bevel. So this loop, this other loop, and the three edges around it. So let's hit enter. On the poly bevel, we just need to say the bevel group, and let's put some low distance value like 0.001, and we want more division, so let's put 8 like before. Finally, we want to fill this part that has left as an open surface, so we can just create another circle, merge with this poly bevel node, and on the circle and for the circle we want to be 3 division as side, and for the circle we want to be 3 division. Let's drop down the uniform scale, rotate it minus 30 degree on the Z axis and increase the size a little bit. And also we want to offset it on the Z, and instead of doing it manually, we can use the first poly extrude distance, which is this one. So let's copy the parameter, go back on the circle and paste relative reference here, and maybe give it a little bit of offset. So let's say plus 0.02 and maybe another 0.002. So it will be slightly offsetted, and also rotate it by 180 on the x-axis. Now let's create some normal for the circle and also some UV. So let's take another UV flatten. This time there's no need to write anything because it's just a triangle, so it will automatically be like this. So we have our full geometry. Now this is the mesh that we are going to take into Substance, and we are going to create the material on a single piece and then reuse that material for every other pieces. Because given the nature of an icosahedron, you will never see two faces oriented the same way, and the fact that they're sharing the material, it won't be noticeable. But before taking this mesh into Substance, we actually need to adjust some things. So the first thing is to clean any unnecessary attribute that may cause problems to Substance. So on the right side, we have only position for the point, normals, and UV for the vertex. And this is exactly what we want. On the left side, we still have this count point attribute, so let's delete it with an attribute rename. On the point tab, we put a star to delete every attribute because the position can't be deleted, so we are good to go. Now we need to find a way to make our subset, because into Substance we want to create three materials. One for the front part, one for the side and the back, and a third material for the curved part. And Substance is able to recognize those subsets if we put those into different groups. So we can easily create a group for our emission material by dropping down a group node after the normal. We just want to include everything, and we want to call it emission underscore material. For the other groups, let's create a group combine node, and we can say that our side material, so side underscore mat, it will be equal to our back plus our sides. So we have our second group, and for the front group, let's take another group combine after the side material. We will call this front underscore mat. It will be equal to everything minus, so subtraction, the side material. Lastly, we want to delete all this group we don't need, meaning these two group on the edge and also the back and the side. So let's take a group delete node, and we want to delete back, we want to delete side, and we want to delete all bevel and seam on the edge. So back here we have position, normal, UV, and the three groups we need for the different materials. Now we can lay down a ROP Alembic output. We will export in Alembic format, and let's rename it as core piece. And we want this to be saved in the $rip folder with this $s variable, so it will take the node name, point ABC, which stands for Alembic format. So now our geometry is ready for the texture. Also, before exporting, I'm seeing some normal issue over here, and I believe they are caused by this fuse node. Yes, this is actually too high of a value and is fusing points which don't need to be fused, so let's drop down the value with another 0. And this should have fixed the issue. So back to the ROP node. Also, let's save it inside the geo subfolder and hit the save button. Now we can hop into Substance and create our texture.